the place if you want to get down. Put your hands in the air. Bob O.B., drop the beat now.
Hello everyone, welcome to lesson 5.4 on another rule for finding derivatives called the quotient rule. We'll start this lesson the same way we started the last lesson on the product rule, answering a question, true or false. If I have a function, p of x, that's equal to f of x divided by g of x, then the derivative of that function, p prime of x, is equal to f prime of x divided by g prime of x. We want to test and see if this is true. And we'll do this the same way that we did in the product rule lesson. I will give you some functions. So let's say that f of x equals x cubed and g of x equals 2x squared. That would make p of x equal x cubed over 2x squared. So we want to test and see if this is true, and we'll do this two ways. So one, we'll try this the way we learned the very first day that we learned about derivatives. So if p of x equals x cubed over 2x squared, I can simplify this to 1/2 x. And then you can find the derivative. The second way we can do this is by trying what I'm proposing that derivative is equal to. So if p of x is equal to x cubed over 2x squared, see what you get when you find the derivative by taking the derivative of the top and dividing it by the derivative of the bottom, and compare. Okay, so try that now. If you've done this properly, you should have found, for number one, that the derivative of p of x is equal to the constant 1/2. Okay, and we know this is the right answer because of the methods we use to find the derivative. Testing this to see if what I proposed, that the derivative is the derivative of the numerator divided by the derivative of the denominator, testing that to see if that works, I ended up with 3/4 x. So 1/2 does not equal 3/4 x, which implies that this second method of finding the derivative does not work. So we need to find a way that does, because when we have quotients, we're not always going to have something as easy and as simple as x cubed over 2x squared. So this leads us to derivative rule number 8, the quotient rule. If my function p of x is equal to f of x divided by g of x, then my derivative of p of x is going to be equal to the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, all divided by the denominator squared. So using the functions from the previous example, f of x equals x cubed, g of x equals 2x squared, let's find p prime of x when p of x is x cubed over 2x squared. So finding the derivative using this form above, we'll take the derivative of the top term, 3x squared, multiply it by the bottom term, which is 2x squared. From that we'll subtract x cubed times the derivative of the denominator, which would be 4x. That's going to be all over the denominator squared. We know from our previous example that p prime of x should equal 1/2. So I need to manipulate this to make this true. So I'm going to expand everything in the top and simplify. I get 6x to the 4th minus 4x to the 4th all over 4x to the 4th. Continuing to simplify, the numerator becomes 2x to the 4th divided by 4x to the 4th. Some things cancel, my variables. So I get the fraction 2/4, which reduces to 1/2. And this is the same as the derivative that we found in the first example, so we know that the quotient rule works. Let's do a harder example of the quotient rule now. If I have h of x is equal to 3x minus 4 over x squared plus 5, and I want to find h prime of x, well, h prime of x is going to be equal to the derivative of the top term times the bottom term minus the top term times the derivative of the bottom term all over the bottom term squared. So the derivative of the numerator is just 3 times the denominator, x squared plus 5. I'm going to subtract 3x minus 4 times the derivative of the bottom term, which is just 2x. And that's going to be all over x squared plus 5 squared. So of course we need to simplify this. So distributing, I'm going to end up with 3x squared plus 15 subtract 6x squared minus 8x and as a suggestion I would say do not expand the denominator. So I'll leave that as x squared plus 5 all squared. Simplifying now, I can continue to distribute that negative sign into these brackets. So I'll have 3x squared plus 15 minus 6x squared plus 8x all over x squared plus 5 squared, which then becomes negative 3x squared plus 8x plus 15 all over x squared plus 5 squared. Okay, so there's two examples of using the quotient rule. We will do more in class and more throughout the week. If I were you right now, I would be making a one-page list of all the derivative rules you've learned so far. I believe we've learned 8. We're going to do a few more in class in the following days and in videos in the following days that you can add to the list and refer to as you're studying. We are gearing up for a test likely later in the week.